Ray 46 has come into the Chesapeake District Championship with 2 blue banners. Now, with this impressive robot and seeing the amazing note handoff, auto runs, and design overall, let's take a look behind the bumpers and see just how this robot works and some of their design iterations that I've done in the past.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support.
All right, so let's take a look at your robot. So it's really, really clean, really flows nicely. Explain a bit about the about the note intake and whatnot.
Yeah, so at the beginning of the season, we were deciding over the bumper or under the bumper. We decided to go under the bumper, just keep it safe. Even now, I think, we have no regrets about it, as, we've seen a lot of over the bumpers get destroyed. So intake, we have almost a full width intake under the bumper. That will feed into our transition or our indexer, which kind of compresses the note into our pivoting arm. So then once it's in the arm, you want to take, yep. So then from here, we have options. If you want to go speaker, we can shoot out like that. All right. If we want to go amp, we'll pivot the arm all the way up. We'll eject it like that using the chamfer mechanism that we saw from our friends. Additionally, for our trap, we do the same thing. We use that same mechanism, and we also have our hooks over here. So for our climb, we have 2 T-slots and 2 hooks attached to the T-slot. It allows us to pull our robot, get it as high up as possible, and it's worked very well for us. Also, we have a steel chassis, which I'm very proud of. We were initially overweight with it, so we had to switch our intake to aluminum, or the intake side to aluminum, but it's worked very well. We've not bent it, and I'd be surprised if someone does bend it.
All right. And so you guys have talked about going through multiple different iterations of different parts of the robot. So explain a little bit on how that was for you, why you went through different stuff, and what the choices you made exactly.
All right, so I'm gonna start with being overweight. So because we were overweight, initially we had a pneumatic brake system on our arm. Of course, since we were overweight, we had to replace that. So we have these 2 nested torsion springs we came up with. Initially, the arm was around 20 pounds of weight, and that comes down, of course, a lot of force. This little nested spring here makes it so that that weight can be moved up and down with your pinky. It takes a lot of the force away from the motor and transfers it, of course, from potential energy of the spring into kinetic, and helps us with weight of that. Next little iteration is with the hooks. Hooks have gone through around 3 iterations based on driver input for do we need this to be longer? Do they need to be a different shape so we can catch onto the hook? We even added these little triangles so we could better move the chain into a better position. Our next iteration that we've gone through is with our shooter wheels. Initially, we had 2 of the same wheels. We found, though, that we couldn't really get enough spin on the note, so it wasn't stable in flight, and it warbled around a little bit. So we've kind of gone to these 2 different wheels of little different size and, of course, different material. And we found that that's really put a spin on it, and we can better shoot from distance about that.
And so you guys have also gone through the competition with some impressive auto routines, some impressive vision tracking. So explain a little bit about how you guys do all that.
Okay, so the first thing I'll go over is auto pathing. So this is the first year we've implemented Pathplaner in a season. For our first few events, we did Pathplaner paths, we did 4-note. And then coming into districts, we found the need to switch to Choreo to kind of optimize our paths more and to get more notes. So we have a 4+1 and we have a 6+ or 5+1. So we have better autos that are more flexible with other alliance partners as well. Some of the vision stuff we did. So as you can see, We have 4 cameras on the robot, 4 Articams running off of a V-Link coprocessor, and we're running photon vision on all of them, multi-tag tracking. This allows us to get a really good pose estimate and then make sure that we always know where we are on the field. This helps a lot with distance-based shooting. So our driver has an aim assist on it. So all he has to do is click a button and it will automatically target to the speaker and automatically distance-based shoot based off of the April tags. Currently, we're working on an amp line. So all he has to do is press a button and it drives to the amp and scores. But that's in the process.
All right. Well, on behalf of First Updates Now, thank you guys so much for taking time out of the day, and good luck to you guys in the rest of the competition.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.